Today we're going to solve quadratics using factoring, but before we do that, we kind of need to answer some questions, right? What is a quadratic? Does anybody remember? Definition of a quadratic equation.
4.
4 has nothing to do with quadratic, actually.
I know there's an x squared, right?
Yeah, there's an x squared. That's correct. Solving quadratic equations using factoring. So if we're going to solve quadratics, we need to define what a quadratic is. Okay, so we're going to look at a standard form for a quadratic equation. The standard form of a quadratic equation is ax squared plus bx plus c equals 0. Okay, the only limitations on this standard form, does anybody remember the limitations here? Anything that's restricted?
It has to be positive?
No, c doesn't have to be positive. X squared has to be the biggest exponent to have a quadratic, but what were you going to say about a, Robert? A doesn't have to be positive in a quadratic expression. Okay, but that's a has to be positive in standard form for a linear equation. But the restriction is on a. A cannot equal 0, right? Because we have to have a square term in order to be considered a quadratic equation. So this a term has to be there. It can be 1, it can be negative, it can be a fraction. It can be anything, but it can't be 0. Because if it is 0, then we would just be left with bx plus c, which is a linear expression and not a quadratic expression. Okay, so this is kind of a review of what we've looked at. In this expression, this is the quadratic term. Okay, bx is the linear term because it's first power, and c is the constant. It's just a number. It doesn't change. It's not really affected by any changes that we make in x. Okay, so the c term, and that is a quadratic expression. We're going to look at 3 techniques for solving quadratic expressions in Algebra 1. In Algebra 2 and some of the higher maths, you'll look at 4 different techniques. Okay, so you'll learn 3 of the 4 techniques for solving quadratic expressions over the course of this week. All right, but a quadratic equation is different. Now let's go all the way back to the first part of the course. What is algebra? I haven't asked that question in a while. What is algebra? Branch of mathematics where we learn how to learn the skills necessary to solve all types of equations. So I've kind of likened it on many occasions to Algebra 1 is like dribbling is to basketball, right? We're not in Algebra 1, you don't play a lot of math. You're just learning the skills that you're going to use to play math later. So it's a lot of skills that we're learning. Solving quadratics is this. Now, what was the who can remember way back again? What does the fundamental theorem of algebra say? The fundamental theorem of algebra. We talked about this during week 1.
We've never talked about it until now, really.
We did. The fundamental theorem of algebra says that a polynomial equation of nth degree has n solutions. So a 5th degree polynomial has 5 solutions, or up to 5 solutions. A 6th degree, in other words, an equation that has a 6th power in it, x to the 6th, would have up to 6 solutions. So this quadratic equation is a 2nd degree polynomial equation, and so we're expecting a 2nd degree polynomial equation to have how many solutions?
Sorry.
No, that's okay. It could have up to two solutions, right? Less than or equal to 2 solutions. So we have to learn to find 2 different answers to these polynomial equations. Quadratic equations could have up to 2 solutions, all right? Because it's a 2nd power. If this was x cubed in this equation, then we'll be looking for 3 solutions. And when you get to Algebra 2, you'll be solving 3rd and 4th and higher degree equations. But all the foundational techniques come from solving the quadratic. So this is a very important skill we're looking at here. Okay? Now, One other thing that we're going to that's going to be necessary for this is called the zero product rule. So this is the zero product rule. If any of you ever heard the zero product rule before? The zero product rule has to do with zero, and what does product have to do with? Multiplication, right? So the zero product rule says if A times B equals 0, what conclusion can we draw? Say that again.
One of the variables is 0.
Either A equals 0 or B equals 0, right? Why?
Because every time you find 0, it equals 0.
You can't multiply anything and get 0 unless you're multiplying by 0, right? You can't multiply anything by 1/2 and get 0 unless you're multiplying 0 times 1/2. Okay, so the conclusion that we can draw is that either A equals 0 or B equals 0. And this is called the zero product rule. A summarization of this mathematical formula here would be that the only way you can multiply and get 0 is if you're multiplying by 0. All right, so if you ever had a simple equation to solve like this, A times B equals 0, you know the two solutions. Either A has to be 0 or B has to be 0, or they could both be 0. Right? So that's just kind of common sense logic. All right, so what if we extended that to something like this? What if we had this expression and we had x plus 4 times 2x plus 1 equals 0? How many things are being multiplied here? 2 things, right? I got this thing and I've got this thing. So how would I make a direct application of this problem to the zero product rule? One of these 2 things has to be 0, right? Either this thing has to be 0 or this thing has to be 0. And we did this a lot in earlier on in the class when we were talking about excluded values in denominator. What value would make this denominator equal to 0? What value of x do we have to throw away because it's a bad value? We were finding zeros then, and we're going to be finding zeros now. So in this expression, either x plus 4 has to be 0 or 2x plus 1 has to be 0. One of the 2 things that we're multiplying has to be 0, and that gives me 2 solutions, right? What would the 2 solutions be? For here, x equals -4. We can solve that practically by observation. On the right side, if we subtract 1 and divide by 2, we get x equals -1 over 2. -1/2. Okay? Easy enough? Now, let's back up a little bit. What kind of equation is x plus 4 times 2x plus 1?
Quadratic.
How do you know it's a quadratic equation, Mac?
4 numbers.
No?
Because if you multiply 2x times x, you'll get an x squared.
Yes, because if you FOILed this out, what would you get? 2x squared, 8x, and x is 9x, and 4 times 1 is 4. So we just solved that quadratic equation. We solved it from factored form. So to use the zero product rule and to solve a quadratic equation by zero product rule, first of all, it has to equal 0 because that's the zero product rule. And then we have to have 2 things that are being multiplied that equals 0. Now, what do we call it when we break something up that's being multiplied? Or what do we call it when we break something up into pieces that are being multiplied? We call it factoring. Okay, so the technique that we're looking at today is solving quadratic equations by factoring using the zero product rule. Okay, so the zero product rule is going to allow us to solve quadratic equations by factoring. All right, so let's dive in, and here's an example. X squared plus 5x plus 6 excuse me, equals 0. X squared plus 5x plus 6 equals 0. It's equal to 0. Right? So I can use the zero product rule if I can break this up into things that are being multiplied, right? Can anybody break up the left side of this equation into two pieces that are being multiplied? What would it be, Chase?
X.
You know?
X plus. Okay, never mind.
No, you're good.
X plus 3 times X plus
X plus 3 times X plus 2, right? So we have to remember our factoring skills here. This is a trinomial, so we're just looking for, and Gray, you were right about that probably if you'd said what you were thinking. But if you find the factors of 6 that add up to 5, what are the factors of 6 that add up to 5? 2 and 3. So this will factor as X plus 2 times X plus 3. Okay? Easy enough, right? We've done this skill over and over and over, and you guys have gotten pretty good at this, particularly this simple factoring skill. But now we're kind of putting the skill to use. What's the importance of factoring? Well, one of the very important things that you can use factoring for is to solve quadratic equations. Set it equal to 0, factor the left side, and now we have two things being multiplied that add up to 0. Either x plus 2 equals 0 or x plus 3 has to equal 0. So what are the two solutions that we're going to get out of this? -2 or -3. And that comes simply from setting these factors equal to 0. Either x plus 2 is equal to 0 or x plus 3 is equal to 0. Really simple one or two step equations are always going to result from this. So x equals -2 or x equals -3, and that's the two solutions. Why are we looking for two solutions here?
Two numbers.
Because A or B can equal.
Because A or B can equal 0 if we go back to the zero product property, but specifically related to the original equation, how do we know we're looking for two solutions? Because it's a second degree equation. Yeah, second degree equations. We're looking for two solutions. It may not have two solutions. It may not have any solutions, but we have to look for two. Sometimes you'll only find one. Okay? Easy enough? So what you've got to condition yourself to at this point, and really for all the techniques that we're going to focus on in this class, if you have an x squared, you have to set it equal to 0 in your equation. And you're going to use one of the techniques. The two prominent techniques will be factoring and this. Now you could check these just like you check any equation. You can plug in the values for x that you just found. If you plug in a 2, if x equals -2 or x equals -3, if you plug those in, you get a true statement, right? In both instances, you get 0 equals 0. So you can check these solutions just like you check a regular linear equation, which we just finished testing on. All right? So solving quadratics using factoring. One more, or a couple, we're going to work with several examples of these, but here's another example. X squared minus x minus 12 equals 0. Is this a quadratic equation?
Yes.
Why is it a quadratic equation?
X squared.
It has an x squared, right? That's the highest exponent. If we had an x cubed in this equation, we got to use different techniques. Okay? So you guys know how to solve linear equations quite well. Now we're learning how to solve second degree equations. Later on you learn how to solve third and fourth and fifth degree equations. And they have 3, 4, and 5 answers you have to find. Okay? So x squared minus x minus 12. It equals 0, which is good. That's what we want. Because we can do what? Factor and use the zero product property, right? So what's the factorization of x squared minus x minus 12? Billy, you got this, buddy? What's the factorization of x squared minus x minus 12? Stay focused. X minus 4 times x plus 3. Yes. Keeping in mind that it has to equal 0 if we're going to use the zero product property. Why is that? What if it was equal to 16? Could I factor the left side and just find two factors that multiply to be 16? What's wrong with that thinking? Because there's an infinite number of things that multiply to be 16, right? Yes, there are. 16 over 3 times 3. 16 over 4 times 4, 16 over 5 times 5, 16 over 6 times 6, 16 over 7 times 7, 16 over 8 times 8, 16 over 9 times 9.
Okay, why are we talking about 16?
Because I'm just emphasizing the importance that this equation has to equal 0 to use the zero product property. There is no 16 product rule. Okay, but multiplying to get 0 is very unique. You have to use 0. All right, so x minus 4 times x plus 3 equals 0 means what? It means that either x is 4 or x is 3, right?
Negative 3.
Negative 3. Thank you, Mac. Subtract 3.
Is this all we're doing?
Yeah, but it gets a little more difficult. Why? How could this get more difficult?
X squared has
The factoring would get more difficult, right? You put a number in front of the x squared and the factoring game changes, right? You have to multiply the first. We'll get there in a second. Okay? Let's look at another one. I'm going to skip through how you would check these, but that's how you check those if you go. So this one's a little bit more difficult. Okay, it's a little bit more difficult because there's a 4 in front of the x squared. It's still equal to 0, which is good. We need it to equal 0 to use the zero product rule and factoring. Solving quadratic equations is kind of always a good idea. If x squared shows up, set it equal to 0. Then you can try to factor it. If it doesn't factor, you can use the quadratic formula, which we haven't learned yet. But that's the two techniques that we're going to kind of focus on. We'll do square root property as well because it's kind of easy. Yes, no, I'm sorry. We have everyone here.
All right, thank you.
All right, what's the factorization of 4x squared minus 3x minus 1? Four times 1 is negative 4, so I'm looking for the factors of negative 4 that will add up to be negative 3. What are they? Negative 4 and positive 1. So the product of these two terms has to be negative 4x plus 1x. Can I use 2 and 2 to get those two terms? I cannot use 2 and 2, so I have to use 4x and x. All right? 4x times something over here has to give me negative 4x, which means that something has to be negative 1. And then x times something here has to give me plus 1x, and that has to be plus 1. Nice. Okay? Have I told you guys all year long how important factoring is? It's huge. Okay? So negative 4x plus 1x gives us negative 3x, and that's the factorization that we're looking for. 1 times negative 1 is negative 1. You can always, and you should always, do a quick check of your factoring to make sure that it multiplies to be what you get.
Where did you get negative 4x plus 1x?
That's what we have to get when we multiply first and last terms. The factors here, negative 4x plus 1x. This is how we've factored these expressions all along.
Yes, sir.
Okay, so negative 4x plus 1x gives us negative 3x. So this will factor as we see there, 4x plus 1 times x minus 1. Then when we set each of those factors equal to 0, what do we get? Do what? What are the two answers we get here? Yeah, that doesn't work.
Oh, okay.
Because 2x times negative 1 is not negative 4x. It's negative 2x. This would multiply to be 4x squared minus 1. All right, so we'll set each of these factors equal to 0. Y'all are awful quiet. I know it's Monday. 4x plus 1 equals 0, or x minus 1 equals 0. If 4x plus 1 equals 0, then x equals negative 1/4. And if x minus 1 equals 0, then x equals 1. All right, so my two solutions are negative 1/4 and positive 1. Okay, easy enough? All right, let's look at another one. What is immediately different about this problem? Do what?
They didn't have a number in front of the x squared.
The order, it's not in what?
Standard form.
Oh, 'cause now we're speaking math, right? This is not in standard form. The standard form of a quadratic equation is ax squared plus bx plus c equals what? 0. Okay? Now, in 3 of the 4 techniques, well, 2 of the 4, but 2 of the 3 techniques that you'll use prominently, and the 2 techniques that you'll use the most, you always want your quadratic equation to equal 0. So the first thing we need to do is what? Subtract 7x from both sides, and when we subtract 7x from both sides, we get x squared minus 7x plus 10 equals 0. And I want it in that order because that's standard form. It's quadratic because it has a square, so I'm looking for 2 solutions, and I'm going to find those 2 solutions, in this case, by factoring, using the 0 product rule. What's the factorization of x squared minus 7x plus 10?
X minus 5.
X minus 5 times x minus 2. This is one of those instances where we're multiplying to get a positive and adding to get a negative. So both factors have to be negative. So we'll have x minus 5 times x minus 2 equals 0. Then we're rolling, right? Set each factor equal to 0. And when we set each factor equal to 0, we end up getting x equals 5 or x equals 2. Okay. What's different here? Which term is missing? We gave the terms. There's 3 terms. The linear term is missing, right? The first degree power. X to the first is missing. That's the linear term. The quadratic term is there, which means we still have a quadratic equation. And we're still going to try to solve it by factoring, putting it into standard form. So what's the first thing I need to do here? Subtract 9. Now can anybody see what a solution is going to be? What do you square to get 9?
3.
Or?
Negative.
Yeah, so you can see the solutions, right? 3 or negative 3 would work. Let's see if the factoring confirms those 2 solutions. So set this equal to 0, we would do what?
Subtract 9.
Subtract 9 from both sides. Now, how do you factor x squared minus 9? Let's do a quick review here of how you factor 2 terms. What's the process for factoring 2 terms? Greatest common factors first. Difference of squares is what we look for next. Now you can also factor cubes, but we didn't cover cubes. We'll save that for algebra 2. You can factor cubes with there's 2 terms also. But the only thing you can do with a binomial, which is what we have here, x squared minus 1 is a binomial, 2 terms, is a GCF or difference of squares. Is x squared minus 9 a difference of squares?
Yes.
Yes, it would factor as x plus 3, x minus 3. That's exactly right. Okay, some of you guys really learned this when we went through it, and you could do a quick check of this, but anytime you multiply by conjugates, x minus 3 and x plus 3 are called conjugates, you get a difference of squares. All right, so it is going to confirm it, right? If each one of these is set equal to 0, x minus 3 equals 0 means x equals 3. X plus 3 equals 0 means x equals negative 3. Pretty easy? I need to see if I can find a problem on here that will challenge you. I guarantee you this one will be challenging. Not sure why this problem always challenges Algebra 1 students and college algebra students alike, but it challenges them. Is this a quadratic equation?
No.
Yes, it is.
Why not, Mac?
No quadratic term.
It does have a quadratic term.
Where's the quadratic?
X
No, you
squared.
just don't have a constant.
I don't have a constant. Do I have to have a constant to have a quadratic equation? I don't, but I do have to have a quadratic term, and the x squared is the quadratic term. Okay?
Sorry.
So it's equal to 0, which is good because I can't use the zero product rule unless it's equal to 0. So I can attempt to solve this by factoring, but here's the problem that a lot of students have with this. How do you factor x squared plus 5x? We just talked about it, right? How do you factor two terms?
Greatest common
GCF and then a difference of squares we'll look for. We're not going to have a difference of squares here because we don't have a difference. X squared plus 5x, not a difference, right? But can we take out a GCF?
Yes.
What GCF can come out of this? X. So this will factor as x times x plus 5. Yeah, if you wanted to check it, you could. X times x is x squared. X times 5 is 5x. So that is the correct factorization. And students still get stumped from here. How many things are being multiplied here? 2 things, right? I got an x and an x plus 5. So one of those 2 things, either this x right here or this x plus 5 right here, one of those 2 things has to equal 0. So I can set x equal to 0, and guess what? X equals 0 is one of the solutions. I don't even have to do anything to solve this equation. That is it. X equals 0 is one of my solutions. All right, and the next solution is going to be x equals -5. Can you do a quick check of that? What do you get when you plug 0 into this original equation? You get 0 squared plus 5 times 0, and that's equal to 0, isn't it? If you put -5 in there, you get -5 squared plus 5 times -5. And that's 25 minus 25, which is also equal to 0. So both solutions check. All right? Okay? So solving quadratics is easy if you know how to factor, and you guys do know how to factor. But the problem, the downside to using factoring to solving quadratics, what would that be? You can't always like factor. That's exactly right. You can't always like factor. Okay, so you have to use other techniques, and we're going to learn other techniques for solving quadratic equations a little bit further down the road. All right, but today, that's it. Solving quadratic equations by factoring. What are the 2 things we have to make sure? We have to make sure that it's quadratic, that it's in standard form, equal to 0, because if you're going to solve by factoring, you have to use the 0 product property, and that means it has to be equal to 0. All right?